Just like with parabolas and other conic sections, if we want to convert to the general graphing form, we're going to need to complete the square. What's different about the circles is that we're going to need to complete the square for two different variables. We have the start of something for the x's, and we have the start of something for the y's. That means we're going to have to complete the square for both. So what we want to do is get everything sort of organized. We're going to put all of our x terms together, all of our y terms together, and everything else just goes to the other side of the equation. Then we're going to get ready to complete the square for both of these variables. So we have x squared, and we also have 6x. And when we complete the square, we know we're going to add something, so I'm going to get that little thing ready. Now for our y terms, we have y squared. We also have negative 2y, and we know when we complete the square, we're going to add something. So what this is going to equal is negative 2, because we moved the 2, plus 2 somethings, the something from the x's, plus the something from the y's. Now let's go ahead and complete the square for each of them. We're going to rewrite x squared plus 6x plus something as a perfect square in factored form. So we have x, now b divided by 2, which is 3. So we're really doing x squared plus 6x plus 9, which means on the other side of the equation, there you go, we need to add 9. Now for our y's, let's get ready to add those. We're going to rewrite y squared minus 2y plus something as a perfect square in trinomial in factored form. So again, we're going to need to do b divided by 2, which is negative 1, squared, which is 1, which means on the other side of the equation, we also have to add 1. That's what makes this kind of completing the square a little trickier, is we have to add two different things. So I'm going to simplify the right-hand side, and it looks like we have negative 2 plus 9 plus 1, which is 8. So we have our equation in the general graphing form. So now we know some stuff about this circle. We know that this circle has a center of negative 3, 1. And the square of the radius is 8. So the radius is the square root of 8. Which can also be simplified. We can pull out the 4, which is 2 times the square root of 2. So again, the only thing that's different this time is we're completing the square twice. We still use the same complete the square methods. So let's look at another one. I know this is a circle because x and y are both squared and they have the same coefficient in front. So let's organize our equation a little bit better so we can see what needs to be done to complete the square. I'm going to put all my x terms together, leave my space for my something, then I'm going to put all my y terms together, and I'm going to leave my space for the something. And on the other side of the equation, we're going to subtract 32, and then plus something, plus something. I run out of space all the time with these. Alright, so let's get started completing the square. B divided by 2. Looks like we have negative 6 divided by 2, which is negative 3. Square that, and it's 9. So remember that 9 needs to get added to the other side as well. So now let's do our y terms. B divided by 2 is going to be 7, and 7 squared is 49. So that's what also goes on the left-hand side of the equation. Now, we're almost ready. We almost have our graphing form. All we need to do is simplify the right-hand side. So we need to do negative 32 plus 9 plus 49. This gives us a total of 26. I think, check my math. Yep. So we have our graphing form equation, so we could go ahead and we could graph this if we wanted to, because we know a couple things. We know that the center of our circle is 3, negative 7, and we know that the radius of the circle is the square root of 26. We can't simplify the square root of 26 anymore because no perfect squares go into this. So if we wanted to graph this, we could just graph our center, 3, -7, and we would need to go out the square root of 26 in any direction. Square root of 26 is just a little bit more than 5, so our circle would be down mostly in that bottom quadrant. Alright, just a couple more because it takes a little bit of practice to remember how to complete the square, remember to do it more than once. So this is another circle, and again, we know it's a circle because x and y are both squared and they have the same coefficient. Now before we worry too much about having to factor out a and remember all those complete the square rules, look at every term in this equation. Looks like every term in this equation is divisible by 2, so we can do a shortcut. We can divide the whole equation by 2. This means every term will be divided by 2. So then we end up with x squared plus y squared minus 2x plus 2y equals 11. So this is much simpler for us to complete the square. We'll gather all of our x terms together and get ready to complete the square with those. And we'll gather all of our y terms together and get ready to complete the square with those. And then on the other side, we didn't have to move anything. That 11 was already there. And we're going to add two things, one from the x's and one from the y's. So when we complete the square with the x's, b divided by 2 is -1. We're squaring it, so we're adding 1. And then we're remembering to add 1 to the other side as well. Now with our y's, b divided by 2 this time is +1. Squared is 1. Add that to the other side as well. So when we finish up our equation, we have 11 plus 1 plus 1, which is 13. So we have our equation, our general graphing form equation for the circle. This circle has a center of 1, -1, and the radius is the square root of 13. Let's think about what this graph would look like. We have a center of 1, -1, and the square root of 13 is the radius. So to graph it, we need to go out the square root of 13. Well, the square root of 13 is between the 9 and 16, which is 3 squared and 4 squared. So we know our number is between 3 and 4. So if we go out that far in every direction, we can draw our circle. This is just one last example to highlight the fact that a circle equation has the same coefficient with the x squared term and the y squared term, and how usually that can be divided out. In this case, everything is divisible by 3, so we can divide the entire equation by 3. So when we complete the square, we will be completing the square with x squared plus y squared plus 6x minus 2y equals 15. Again, yay, we don't have to move anything, we just need to reorganize. So we have x squared plus 6x plus something. And our y terms would be y squared minus 2y plus something. Then on the right-hand side, we already had that 15, and then we know we're going to add two somethings. We're going to add a something for the x and a something for the y. So when we complete the square, we'll do b divided by 2. So we get x plus 3 inside the parentheses. Squared is 9, which means I need to add 9. Then with our y terms, we're again going to do b divided by 2, -1. Squared is +1, so that's what we're going to add to the other side. So when we simplify, we get 15 plus 9 plus 1 on the right-hand side, which is 25. So now we have our graphing form of the equation, which helps us find out information about the circle. This circle has a center of -3, 1, and yay, a nice radius this time. The radius is 5 because the square root of 25 is 5. If If you wanted to graph this one, you would graph the center, and then you would go out 5 in each of the directions, and you would be able to graph your circle. So completing the square for circles is not much different than completing the square for parabolas, except you have to complete the square twice. This is something that will come up when we look at ellipses and hyperbolas as well.